This lesson is on balancing equations. Balancing equations goes off the law of conservation of mass. It basically states that mass can't be created or destroyed, that you can change its form. And so basically what that means is that the mass of the reactants has to equal the mass of the products. If the masses don't match or don't equal, then you're going to have to balance the equation out to make them equal. A couple of things in this is basically just a review, but a couple of things for you to remember. If you have a compound, let's say you have HCl, and you need two H's, you can't just add a subscript in there. That's a no-no. If you needed two H's, you can't put a number in between and split the compound. That is a no-no. If you need two H's, you must put a large number called a coefficient in front of the entire compound. So that means that not only do you get the two H's that you need, but you're also going to get two Cl's. So keep in mind that this is like math. So when you stick this number out here, this coefficient, you're going to multiply or distribute that number to both of the elements, or however many elements there are there. All right, let's do some practice problems. We're going to take BaCl2 and add it to H2O. That's going to give us BaOH2 and HCl. Now, keep in mind, this side is the reactant, this side is the product. We want them to equal. So the first thing you need to do is you need to draw a line at the yield sign or the arrow sign and make sure that you know what you have on the reactant side. We have Ba, we have Cl, we have H, and we have O. And on the product side, we have a Ba, we have a Cl, we have H, and we have O. Keep in mind that you need to have the exact same elements on both sides. If you do not have the same elements on both sides, then something is wrong with your equation and it's not going to balance for you, and therefore it's not an actual chemical reaction. So you need to go back and check it. Okay, we're going to tally up. So on the reactant side, we have one Ba, we have two Cl's, we have two H's, and we have one O. On the product side, we have one Ba, and we have one Cl, and here's where it gets a little tricky. So let's go ahead and do the O's, and then we'll do the H's. So this 2 on the outside right here is going to multiply or distribute to everything inside the parentheses. So you would get two O's and two H's. So since I don't have O anywhere else, that's going to give me my two O's. But I have two H's here, plus I have one more H over here. So 2 plus 1 is going to give me 3 total H's. Now, what you want to do is you want to make sure that whatever you do to one side, or what you do to that one H, you make sure you add back. Okay, so we have one Ba on each side. The Cl's are off. We have a 2 and a 1. The H's are off, 2 and a 3. And the O is off, 1 and a 2. Now, don't get fooled by the H's. I know that we have a 2 and a 3. And I can't make the 2 turn into a 3, and I can't make the 3 go back to a 2. And I know that it looks like they could go and multiply to each other and give you a 6. And that's possible. But let's kind of work through the problem and see how this plays out. Let's start with the chlorine. So I have 2 chlorine on the reactant side. I want 2 chlorine on the product side. So let's put a 2 in front of this. That means my 2 is going to multiply to my H and to my Cl. So I just changed my Cl to 2. And now remember what we did a few minutes ago, that you had 2 H's here, and you now have 2 H's here. So that 2 and 2 is going to give me a total of 4 H's on the product side. On the reactant side, my Ba's are still good. My chlorine are now fixed. My oxygen and my hydrogen are off. Luckily, they're together in water. So let's put a 2 in front of the H because 2 times 2 is going to give me that 4 that I need for the H's. It's also going to be 2 times 1 for the oxygen and give me 2 for that. So now if I go through and check it, I have 1 BA, 2 CLs, 2 CLs, 4 H's, 4 H's, 2 O's, and 2 O's. So I would have a 1 here and a 1 here. So I have 1 BaCl2, 2 H2O, yields 1 BaOH2 and 2 HCl. And you have successfully balanced that equation. Now, that one was pretty easy, pretty simple. So now let's look at another one. Let's use MgOH2 and NaCl, and that will yield for us MgCl2 and NaOH. Once again, we're going to use our yield or arrow as our cut point. We need to make sure that we have the elements on the reactant side and product side the same. So we have Mg, we have Na, we have Cl, and in this case, you're going to have to, you can leave your OH together. Because you have an OH here, and it's still together as an OH over here, leave it as an OH. You can split it as H and O, but it's a little bit easier if you leave it all together. On the other side, we have Mg, we have Na, we have Cl, and we have OH. If you notice, I put all of my elements across from each other so they're easier to see. Notice that I have Mg as the first one, and then I have Na as the second one, and so on and so forth. It's just easier for your eyes to see that and make sure that you've got it balanced. So on the reactant side, we have 1 Mg, we have 1 Na, we have 1 Cl. We again have 2 OHs. We're going to keep them together collectively. On this side, we have 1 Mg, we have 1 Na, we have 2 Cls, and we have 1 OH. Alright, let's start with the OH and see if we can't get it balanced. So I'm going to start by putting a 2 in front of this because I want 2 OHs, and that's going to change this to a 2. But it also changed the Na to a 2 as well. Remember, you're distributing. So you're going to get 2 Na and 2 OHs. If we go over to the reactant side, notice that we need 2 Na and we need 2 Cl. The good part is that they're together up here in this compound. So we can just put a 2 in front of them, and we get 2 Na, and we get 2 Cl. So now I have 1 Mg, 2 Na, 2 Cl, and 2 OHs on both sides. Adding a 1 here and here balances out our equation. The last example I want to do for you is what happens with those polyatomics and how to leave them together. It makes it a whole lot easier. So let's do Fe2SO4 3 and water, and that yields for us FeOH3 and H2SO4. Again, the arrow is our cut line. So on the reactant side, we have Fe. I'm going to leave the SO4 together. And now I'm going to look at this water, because if you look on the other side, I have an OH. So there's a trick to this. You can actually rewrite your water as HOH. That way I can have a hydrogen and a hydroxide. On the product side, I have an Fe, I have an SO4, I have an H, and I have OH. So let's get some numbers. I have 2 Fe. I have 3 times this whole thing, so that gives me 3 SO4s. I have 1 H and 1 OH. On the product side, I have 1 Fe. I have 1 SO4. I have 2 H's. And I have 3 OH's. Alright, so let's start on the reactant side, and let's start on the product side. We need 3 SO4s. So I am going to put a 3 in front of H2SO4 because I want this 3 to multiply here and give me 3 SO4s. That also multiplies and gives me 6 H's. So 3 times this 1 SO4 gives me 3 of them, and 3 times the 2 H's that I have gives me 6. I also could clean up the Fe's on this side. I have 2 Fe's over here, and so I could put a 2 on the product side, and 2 times this Fe is going to give me 2 of those, and 2 times 3 is going to give me 6 of the OH's. Alright, when we go to the reactant side, my Fe's are good. I've balanced those out. My SO4s are good. I've balanced those out. I have a 2, a 2, a 3, and a 3. The H and the OH both need a 6. So I'm going to put a 6 in front of this. That's going to give me 6 H's, and it's going to give me 6 OH's. And now I'm balanced. 2, 2, 3, 3, 6 H's, and 6 OH's. And we have balanced this. Now, you could break this apart if you wanted, and you could have done 3 times the 1S and 3 times the 4 O's, and you could have broke that one apart. You could have also broke this into O and H. However, if you keep the SO4 on this side, if this SO4 and this SO4 are together on the reactant and the product side, then keep them together is easier. If your OH here can be split up here, then keep the OH's together. If not, then you'll have to do it by individual elements. I hope that this has helped you with balancing equations. Thank you for watching.